Alrighty then, here we go with some of our favorites. Okay, the conceptual questions. So let's see, which is the correct way to light the light bulb with the battery? That looks good. Okay, so in order for the light bulb to light, both terminals of the battery have to be connected, and the current has to pass through the light bulb. So when we're looking at a light bulb, this is one terminal and this is another terminal. So the current has to go in one way and out the other. And for most light bulb situations, either way would work. But this looks, whoa, hey, this looks good. As the current goes in one way and out the other, let's see what we say. Current can only flow if there's a continuous connection, right? So electrons would actually go like this through the light bulb and then back into the battery. Very nice. Number next. You double the voltage across a certain conductor and you observe that the current increases 3 times. What can you conclude? So Ohm's law, V equals IR, and so this is saying that the voltage and the current are proportional. And so we say that this is an ohmic resistor if it obeys Ohm's law. And it turns out that for most of the resistors, for sort of pretty mellow voltages and mellow currents, it works. But if you really up the voltage and you get some crazy current running through it where it's super hot, right, burning puppies and all, then it would not normally obey Ohm's law. So let's see. If you double the voltage across a certain conductor and you observe that the current increases 3 times, so if we were to double the voltage, we would expect the current to double, not increase by 3 times. So it looks like answer choice B, not obeyed. Alright, and look at this over here. So we have current and voltage being proportional, meaning it's a straight line, not like this. Okay, so ohmic resistors, that's important. Or, well, that'll show up again. Alright, 2 wires A and B are made of the same material and have equal length. So same material, meaning they have the same resistivity, equal length, but the resistance of wire A is 4 times the resistance of B. So that would be A and that would be B. The larger diameter or larger cross-sectional area means less resistance. And so we might even do this, for R and R. How do their diameters compare? So we're interested in this. So hopefully you remember that the resistance is equal to the resistivity, that's the Greek letter rho, length over area. So if this is 4 times, then the area, cross-sectional area, would have to be 1/4. So we're looking at, it's weird. So we're looking at this. So this would have to be 4 times the area if this is 4 times the resistance. And because we remember pi r squared equals area, so the area depends on the square of the radius, meaning diameter as well, or square of diameter. So we have this, that the large diameter would be twice the other one in order to have 4 times the cross-sectional area. Yeah. So what do we say? Resistance of area is less than wire B. Area is related to the radius squared. Radius squared. There's that relationship again. Oh, and here's our formula. What's that thing called? Rho. Oh, here it is again. Alright, a wire of resistance R is stretched uniformly, keeping its volume constant until it is twice its original length. What happens to the resistance? So I think we've seen this question before in some application. We're basically taking a wire like that, we're stretching it so it gets longer and skinnier. So we know that this would have less resistance, this would have more resistance. So yeah, the resistance is going to increase. What happens to resistance? Let's see. Until it is twice. Oh hey, pretty much drawn to scale. Alright, so if it's twice, so this is increasing by a factor of 2, but the cross-sectional area is decreasing by some factor. So you'd have to actually take a look at the fact that the volume stays the same. So we have the volume of the short fat wire equals the volume of the long skinny wire, and volume of a cylinder is pi r squared times height or length. So pi r squared times length. So something like this. So you're giving some thought to, if the length doubles, what's happening to the radius and thus what's happening to the area. And we think it's going to be one of these. Aha! Increases by a factor of 2. So the area is halved, length is doubled. Keeping the volume constant means that if the length is doubled, the area is halved. This increases the resistance by a factor of 4. Okay, so this is our second typo here. Yeah, that looked weird. Shame on you. Alright, but I proofread, well, I kind of proofread this one. But yeah, this sounds better, and I think we've seen this, where it's like 2L up here, and then 1/2 A up here. And so dividing by the fraction, same as multiplying by the reciprocal, and we get that 4 times the resistance. Alright, when you rotate the knob of a light dimmer, so here's my diagram of a light dimmer. It's hooked up to the wiring in the house, which is 120 volts, and here's the light bulb, which goes from bright to dim. Well, okay, dim. So what is being changed in the electrical circuit? The voltage stays the same. All right, and what this actually does, this is a variable resistor. So when the resistance changes, the current through it changes. So let's see, current through it changes, and thus the power output changes as well. Less light means less power is being used up. So hopefully our answer is okay, that's looking good. Light dimmer increases the resistance, which decreases the current, and thus the light actually put out. 2 light bulbs operate 120 volts, but one has a power rating of 25 watts, so that'd be a pretty dim light bulb. Other has a power rating of 100 watts, which is pretty bright light bulb. Which one has the greater resistance? We've seen this question also in some, I think in our homework. So the two equations you should know, PIV and VIR, power equals current times voltage, and voltage is current times resistance, can be combined in 2 different ways to give us 2 different equations for power, based on voltage and resistance, or current and resistance. So if these are both hooked up to 120 volts, less resistance is going to mean more power output. So less resistance means more current flowing, so less resistance means more current for a given voltage, and the more current flows through, the greater the power output of the light bulb. So which one has a greater resistance? And so the greater resistance would be the one that puts out less power because there's less current flowing through it. And I think there's a typo on this one as well. Yeah. So they say it here. The word descriptions are always correct. The bulb with the lower power rating has to have the higher resistance. Lower power rating, higher resistance. So if they're asking which one has greater resistance, then the answer would be this right here. Shame on you. And let's see, heaters. 2 space heaters in your living room are operated at 120 volts. You might be blowing a fuse, right? The circuit breaker if you're running 2 space heaters. Heater 1 has twice the resistance of heater 2. So I just, if I were solving through this, I would probably write this to help keep my thoughts straight. Which one will give off more heat? So let's see, this is totally related to the last question. If we have less resistance, doesn't that mean if this is small, then this is big? Less resistance means greater power output. So hopefully they tell us that heater 2 gives off more heat because it has less resistance. So, alright, so that sounds good. Smaller resistance, larger power output because more current flows. And I think that's it. Thanks for listening.